Welcome to today's video, where we dive into one of the most fundamental concepts in science, the periodic table of elements. While it may seem like just a collection of symbols and numbers, this table holds the key to understanding the building blocks of our world. From the materials that power our electronics to the elements that make up our bodies, the periodic table is at the heart of almost everything we use and experience daily. In this video, we'll explore how the periodic table structure reveals the behavior of elements, how it influences technologies like smartphones and electric cars, and how it plays a crucial role in medicine, energy production, and even our environment. By understanding the periodic table, we gain the power to unlock innovations that improve our lives and solve global challenges. So whether you're a curious science enthusiast or someone just looking to understand how these elements affect the world around you, this guide will show you just how deeply the periodic table shapes our modern world. Understanding the periodic table, its impact on technology and daily life. The periodic table of elements is one of the most powerful tools in chemistry. It organizes all known elements based on their atomic number and reveals patterns in their properties, behaviors, and reactions. By understanding the periodic table, we gain insights into everything from technology to medicine and energy production, all of which shape our modern world. 1. The structure of the periodic table. The periodic table is arranged into periods, rows, and groups, columns, and its structure helps predict how elements behave in chemical reactions. Atomic number. Each element has a unique atomic number, which is the number of protons in its nucleus. Elements are arranged in increasing order of atomic number. Periods, rows. There are 7 periods. As you move from left to right across a period, elements become less metallic and more non-metallic. Groups, columns. There are 18 groups. Elements in the same group have similar chemical properties because they share the same number of valence electrons. Notable groups. Group 1, alkali metals, e.g. lithium, sodium, highly reactive. Group 2, alkaline earth metals, e.g. magnesium, calcium, less reactive. Group 17, halogens, e.g. chlorine, fluorine, very reactive nonmetals. Group 18, noble gases, e.g. helium, neon, inert and stable. 2. Key trends in the periodic table. The periodic table reveals important trends that help us understand how elements interact. Electronegativity. This measures an element's ability to attract electrons in a bond. It increases across a period and decreases down a group. For example, fluorine is the most electronegative element. Atomic radius. Atoms get smaller across a period due to the increasing number of protons pulling electrons closer. The radius increases as you move down a group due to additional electron shells. Ionization energy. This is the energy required to remove an electron. It increases across a period and decreases down a group. Metallic versus non-metallic behavior. Moving left to right across a period, elements become less metallic and more non-metallic. Metals tend to lose electrons, forming positive ions, while non-metals gain electrons, forming negative ions. 3. How the periodic table impacts the world. The periodic table isn't just a scientific curiosity. It affects technology, healthcare, agriculture, and even our environment. Predicting chemical reactions. By understanding periodic trends, scientists can predict how different elements will react with each other. For example, alkali metals, group 1, react explosively with water, while noble gases, group 18, are inert and don't easily form compounds. Material science and engineering. The periodic table helps create new materials with specific properties. For example, stronger alloys and more efficient semiconductors. Lightweight materials for aerospace and high-strength steel for construction. Energy production. Elements like uranium are key in nuclear energy production, while others, like lithium, power rechargeable batteries for electric vehicles, EVs, and renewable energy storage. Biological functions. Many elements are vital to life. For example, carbon, hydrogen, oxygen, and nitrogen are the building blocks of organic molecules. Calcium is important for bones, and iron helps in transporting oxygen in the blood. 4. Real-world examples. How the periodic table affects our lives. Medicine and healthcare. The periodic table aids in designing life-saving drugs and treatments. For example, iodine I is used in X-ray imaging and sterilization. Platinum, PT, is used in chemotherapy for cancer treatment. Iron, Fe, helps in the production of red blood cells. Technology and electronics. The understanding of elements like silicon Si and germanium Ge has led to the development of semiconductors, which are the foundation of computers, smartphones, and the internet. Without the periodic table's guidance, we wouldn't have the microchips that power modern technology. Sustainable energy and batteries. Lithium-ion batteries made from elements like lithium Li and cobalt Co are key to storing energy for electric vehicles and solar power systems. As the world moves towards sustainable energy, understanding these elements helps us store and use renewable energy efficiently. Agriculture. Understanding elements like nitrogen N, phosphorus P, and potassium K has led to the creation of fertilizers that boost crop yields and food production. These elements are essential for plant growth, and they help farmers feed billions of people. Water treatment and environmental protection. Elements like chlorine Cl and oxygen O play crucial roles in water purification and air quality control. By understanding how elements react, we can ensure clean water and fight pollution. 5. The future, sustainability and innovation. As we face global challenges like climate change and resource depletion, the periodic table will continue to help drive innovations in green chemistry, renewable energy, and eco-friendly technologies. For example, graphene, made from carbon, is a revolutionary material that could change electronics and energy storage. Copper and silicon play key roles in solar energy, powering our transition to clean energy solutions. Conclusion: the power of the periodic table. The periodic table is much more than just a list of elements. It's a guide to understanding how matter behaves and interacts with the world around us. From life-saving drugs to advanced technologies, from clean energy to agriculture, the periodic table impacts nearly every aspect of modern life. Understanding it has enabled us to shape a better future, and as we continue to explore its depths, we will unlock even more possibilities for innovation and sustainability. Conclusion: the periodic table is far more than just a scientific chartiste, the foundation of everything around us. From the technologies we rely on, like smartphones and electric vehicles, to the medicines that save lives, understanding the elements and their behaviors allows us to innovate and solve real-world problems. Whether it's creating sustainable energy solutions, advancing medical treatments, or designing new materials, the periodic table is essential in shaping our future. By continuing to explore its patterns and trends, we unlock endless possibilities for progress and discovery.